Hi, fifth grade Cougars, it's Mrs. Balatash, and today we're going to delve a little deeper into the atmosphere. Remember, the atmosphere is this blanket of gases and air that surrounds Earth. If we didn't have an atmosphere, we could not have life on Earth. All of the weather that happens on Earth in our atmosphere happens in the troposphere. That's the first 9 miles of our atmosphere. That's where we live. We live and breathe in the troposphere. One of the things that makes weather really important on Earth and affects our weather is something called the uneven heating of the Earth. Certain Earth materials heat up differently than others, and that can affect wind patterns and weather on Earth. So we're going to do a few little experiments that help illustrate this. Before we get started, I want to make sure you have your notebook. I'm going to turn to the table of contents, and number 8 is going to be uneven heating. And for me, mine is on page 13. After I have done my table of contents, I turn to page 13 and I put the date at the top. And the title is Uneven Heating of the Earth. Then I have 2 questions I want you to write. The first one is, what Earth materials heat up fast? And the second question is, what materials heat up slowly? And then as we do this experiment, as I show you this experiment, I want you to write down some data. So I'm going to give you some information. I want you to write down the data, and then we're going to talk about it at the end. I'm going to put 2 different containers under some light bulbs. The light bulbs have the exact same wattage, so they are transferring the same amount of energy to these materials. One bowl contains soil, one bowl contains water. And basically these 2 bowls represent the surface of the Earth, right? Part of the Earth is covered by water and part of the Earth is covered by rocks and soil and other Earth materials. Before I put them under the light, I'm going to take their temperature. The temperature of the soil is about 18 degrees Celsius. The temperature of the water is about 21 degrees Celsius or 20 degrees Celsius. And now I'm going to put them under the light, and we're going to see what happens to the temperature of these materials when the heat and energy from the light is transferred to these Earth materials, to the soil and to the water. I put a top on the containers to keep the heat inside, and it's actually been more like an hour instead of 30 minutes. And let's take a look at the temperature of the soil. So the temperature of the soil is about 38 degrees Celsius. The temperature of the water is 30 degrees Celsius. So they've both been under the light for the same amount of time. Which one got hotter? The Earth materials got hotter. They got hotter quite a bit more, like almost 10 degrees Celsius more than the water. So it seems like water takes a long time to warm up. Now I'm going to take these materials out of the light, and I'm going to let them cool down for 30 minutes, and we're going to take a look at the temperature again. It has now been 30 minutes, and the soil and the water has had a chance to cool down, and now I'm going to see what the temperature is now. Here's the soil, and it is 28 degrees Celsius. And here is the water. It's hard to take it out. It is 29 degrees Celsius. Now, if I remember correctly, the soil got pretty hot, almost to 40 degrees Celsius. The water didn't get that hot, but it also hasn't really cooled down. So it appears to me that the soil heats up pretty fast, and it also cools down pretty fast. It appears to me that the water takes a long time to heat up, and it also takes a long time to cool down. So you might be wondering, so who cares whether rocks heat up fast, Mrs. Belatash? Who cares if water heats up slowly? Well, that makes a difference to our weather. Remember, immediately over the top of the earth, the surface of the earth, is the atmosphere. And the atmosphere is made out of gas, and gas is the air is touching the surface of the earth. When the sun's energy comes down and heats the surface of the earth, that heat is transferred to the air. And when air touches something hot, it rises, it moves, it gets less dense, and it rises. As illustrated by this little experiment. I have a hot plate here, and it's on, it is giving off heat, I can feel it. And I made a quick little paper plate twirly bird. It's really super fun. And I'm just gonna put it over the hot plate. And you can see that it is spinning. Now, I'm not spinning it. The thing that's making it spin and turn is rising air. When the air gets hot, that's right over the hot plate, it gets less dense and it floats up. And when it floats up, it makes my little paper plate spin. So I can see that the air is moving. Let's put some of this information together and start making sense of why we have winds and different local weather conditions. So we put the soil under some light. We put the water under some light. They were both under the same amount of light at the same amount of time. The soil heated up fast and it cooled down fast. The water took a long time to warm up and took a long time to cool off. Let's keep that in mind when we take a look at the beach. So we're gonna go on a little trip down to the beach. So we're at the beach, and have you ever noticed that it's a great place to fly a kite? Because there's always wind at the beach. And the reason there's always wind at the beach is because of uneven heating of the earth. So the sun provides light and heat. It heats the surface of the earth, but it doesn't do it evenly. Here we are at the beach, and the beach has a lot of water. There's a lot of water. The ocean is right there. And from our experiment, we learned that it takes a long time for water to heat up. So the water is kind of cold. But here we are at the sand, and from our experiment, we know that the sand will heat up very fast. And so the sand is hot. Have you ever been to the beach and you go to the beach and you take off your sandals and you go like, oh, your feet are so hot because the sand is hot. You run to the ocean and you put your feet in the water, and the water is cool and refreshing. So you can see our experiment at work right there. The water is cold, the sand is hot. Now we have to think about what happens to the air right above the sand and the air right above the ocean. The air right above the sand gets hot. And so that hot air rises. The air rises because it's hot and less dense. Now, the problem is that over the ocean, the air gets cold and it sinks. So this air is heavier, it's sinking. This air over the sand is lighter and it's rising. When this air over the sand heats up and rises, there's some space for this cold air to come in. And so the cold air sweeps in off of the ocean, and we have an onshore flow. The cold air moves in because the hot air has risen up. Now, when the cold air gets here, it starts to get heated up by the sand, and then it starts to rise. When that air gets higher in the atmosphere, it starts to cool down and it sinks again. So the hot air rises and the cold air sinks. And we start getting this cycle, and when air is moving, it's called wind. So that's why we have always a nice wind at the beach. The sand gets hot because the sun heats it faster than the water. The water stays cool because it takes a long time for the water to heat up. So we have this constant onshore flow. Okay, we've done our experiment, and I want to do a little review again and talk about what we should write in our science notebook. So, what materials heat up fast? Rocks, sand, soil. Solid earth materials heat up quickly and cool down quickly. What materials heat up slowly? Water. Water takes a long time to heat up, but it also takes a long time to cool off. And this difference, this uneven heating of earth materials, makes a difference to our weather because we set up something called convection currents. So when things heat up, when they rise up, that because they're getting lighter, they're getting less dense, hot things rise and cool things sink. And that circular motion is called a convection current. Maybe some of you guys have convection ovens at home, and that's hot air that is moving in circles inside your oven. So hot air rises because it's lighter, cold air sinks because it's heavier, and it creates a convection current. So our atmosphere protects us and keeps us nice and cozy here on Earth. All weather happens in the troposphere. Uneven heating of the Earth creates wind, which are convection currents. All right, Cougars, next week we're going to talk about the water cycle.